Hello students. In the last two classes, we have all understood a lot about motion, a lot more to be understood, and we just carried out a simple experiment using the carom board in order to understand certain key concepts involved in motion. Motion is a very fundamental and a powerful concept in mechanics. Well, now first and foremost thing, all of you recollect that we had a carom board in front of us and it had 4 pouches, and we had a striker and a player who was playing on the carom board. Okay, fine. Now what we are going to do is, now we are going to imagine that experiment that we did. Experiment means, we kept the striker, we moved it, and through that we understood many things like position occupied by the object. Object here means the striker. Position occupied at different times, speed, force, etc. Now we shall break that into experiment 1, 2, 3, 4 and summarize the whole thing. Fine. So the first experiment. What are the first experiment that we did? Experiment number 1. Okay. So let me draw it like this. We had the carom board, but now I am not going to draw the carom board. This point was the pouch at the corner, and we will take this as the reference, because we have understood that motion of an object is always with respect to a reference point. It always is with respect to a reference point, and reference point is something that we have to fix, and we will give a name to this, usually the name O to this. And then we have seen that the striker, now the striker in the carom board is our object, is the body. Now this was here and we will call this as position P1 at time T1. This is important. It was at position P1 at time T1. Then it came to this position. This position is P2 and at the instant of time T2. Then it was at this position P3 at time T. Well, we have noticed this. That is, we kept the striker and we moved it with our hand. And when it was being moved, it occupied these 3 positions and many more positions like this. We are just marking these 3 positions. And what is important here is that, it is occupying position P1 at time T1, position P2 at the instant of time T2, position P3 at the instant of time T3. This is extremely important, and that is what we have observed. And with respect to this point here, okay, we can address these points like this. That is, with respect to this point, these are the lines that I am drawing with arrowhead. And I am sure students, you know what I am doing here. Well, if you don't know also, it is fine. I am addressing these 3 points with 3 lines with arrowheads. And I will call these lines as R. These lines as, well, R1 bar, R2 bar, R3 bar. Well, if you don't know or if you know, okay, either ways, R1 bar, R2 bar, R3 bar are called position vectors. R1 bar, R2 bar, R3 bar are called position vectors. Okay, position vectors. Okay, now if you don't know what are vectors, what are position vectors, don't bother. I just mentioned it, and At this stage, if you don't know what is position vector, well, I am just pointing those through those 3 points under consideration with respect to the reference point by using 3 lines with arrows. Even that much understanding is sufficient at this stage. Okay, so very important for us. We will now define motion. So how is motion defined here? I think already I have dictated that to you in the class. Now, what is it I have written? The body occupies different positions at different instants of time with respect to a fixed point. That was the first definition that I gave. Now, further, I modified this definition and with a slight modification. You remember, I introduced the concept of time interval. You remember that? Time interval. Okay, so here time interval, I will use the symbol, it's called delta. Delta. Okay, delta t. And in this case, the time interval becomes the time instant t3 minus the time instant t. For example, supposing it was you had a wristwatch and it was indicating time t1 was say 12. It was indicating some time t1, and as I kept moving, the time went on shifting. So t2, t3 was the time, and here I am just stopping this experiment. I'm stopping this experiment at time t3. I started this experiment at time t1. t1, t2, t3 are all in seconds. It's not in hours. So during this time, which time? T3, see, I am moving the duster like this. I started at T1 and T1, T2, T3. I ended at T3. So this time interval T3 minus T1, I am calling it as time interval delta T. Now what I would like all of you to appreciate is, we are considering the motion of a body within this time interval. Okay, what it was doing before time T1, what it is going to do after time t3 is not our consideration. Experiments are always conducted under consideration. Okay, so during this time interval, the body was in continuous motion. I repeat, the body was in continuous motion. What do you mean continuous motion? It went on occupying different positions. It went on occupying different positions at different instants of time. And therefore, the body is in motion. Okay? So the definition for motion now is that a body is said to be in motion during a time interval delta t with respect to a fixed point called the reference point if it occupies different positions at different instants of time. I hope the motion is now very well defined. Okay, students? Fine. So this was our experiment number 1. Okay, fine. Thank you. Well, now we will continue with experiment number 2, the same carom board. Okay, in the second experiment, what we have is that I am representing this. You see this line with this. And what is this? This is the surface of the carom board. Surface of the carom board. Okay. And here we have put boric powder on the carom board and we have taken a nice striker. Therefore, most important thing is there is no friction. There is no friction between what? Between the object. Here object is what? The striker. Okay. Between the object and the board and the carom board. So there is no friction. Okay. So that is the carom board that we have taken. And well, we have placed a striker here. I suppose all of you noticed it. Okay, so this is a solid striker that is kept, right? So what is this now for our experimentation? The striker becomes a body under consideration. Okay friends? Right. Now here also you see we have to understand a very powerful concept. What is that concept? This striker is, now again I will mark a point here. Okay, I will call this point as reference point. Reference. Okay, and of course I will give the same name O to this. Now what do you see? This striker has occupied this position. Say you give name to this position. It is a occupied position P1. Okay, and it has occupied position P1 at the time T1, at the time T2, at the time T3, at the time T4, so on at the time Tn. So what I am trying to tell you is it has occupied this position at all the intervals of time. You see, this is there here and it is there here for this time, this time, this time, this time, this time. Okay, that is, it is there for a long time. So therefore, I will say it has occupied position P1 during the time under consideration. What is the time under consideration for us now here? That is time interval. You remember, we are going to use the concept of time interval. During the time interval delta t. What is delta t? It is Tn minus T. Okay, now what I am trying to tell you here is that this object is in the same position P1 during the time interval delta t. I repeat, it is in the same position P1 during the time interval delta t. Therefore, what is it? Okay, this body has occupied the same position P1 during the time interval delta t with respect to this reference point, and therefore this body is at rest. This body is at rest. Okay, now please appreciate and understand. This is, what is rest? Rest is a concept. Rest is a concept. Right? Okay, no, it appears, it's trivial. Oh, what's a rest? It is okay. No. But you see, as students of SSS, every concept has to be defined. Concept means it's an idea, a well-defined idea, which we are going to use it to understand many things. So, now, in the previous experiment, we have studied the concept of motion. What is motion? This is also a concept. Okay, and now what we have studied? We have studied the concept of rest. Okay, we have studied the concept of rest. Okay, so therefore you see both these concepts are very well identified. Okay, students? Well, now we shall proceed with the third experiment. Okay, so what is our third experiment? Well, our third experiment again, was the same. That is extension of experiment number 2. Okay, experiment number 3. So what is experiment number 3? Again, we have taken the carom board. Okay, so these lines indicate that the carom board is rigid. I mean, it is fixed. Okay, and then again, this point is what? The reference point O. And what is this? This is going to be our striker. Right? This is going to be our striker. And now, well, it is in this position. Now here I am going to draw something like this. Okay. So here you see what I am drawing here. See, other day when we were experimenting with the carom board, we saw that there was a gentleman who was playing with the carom board. That is, he had kept the striker and he was hitting the striker with his finger like this. I suppose all of you have noticed it. And this is this finger of the player. Finger of the player. This is the finger of the player. Now you can see the finger of the player is not touching the striker, so the striker is in a state of rest. Okay. Now the next there is an instant of time when this finger moves and touches the striker. So it is just touching the striker, and after touching the striker, the finger starts moving. The finger starts moving. So as the finger starts moving forward, okay, what happens to the striker? The striker will also move. I suppose you appreciate this. The striker will also move. So the striker which was here now is here. The edge of the striker is here. Now as he further moves his hand, okay, as he further moves his finger, the striker will further move. Okay, I hope this is clear. That is, as long as this finger is touching, the striker is moving. Correct? Okay. Now here, students of physics will not simply say it is moving. Students of physics will not say simply it is moving. Yes, it is moving, but you will advance because you are not seeing, you are going to observe. What is your observation? Well, observation number one. Observation number one, the body, what is your observation? The body is occupying what? Different positions at different instants of time. Isn't it? The striker is occupying different positions at different instants of time with respect to this fixed point. At different instants of time with respect to the fixed point. Okay, friends? So therefore now what is your conclusion? Therefore what? The body is in motion. Now if I say the instant he touches his hand, the time instant is t1, and the instant where he, now you observe very carefully. Okay. Now you observe very carefully that his after he touches this point, this striker will be here. That is, you can see here that he was touching his point till this point. What is this point? Say this is time t1 and this is time t2. Okay. See, that is, I am marking the instant of time when his finger loses contact with the striker. See, from this point to this point, the striker was in contact with the finger, and therefore as his finger is moving, the striker was also moving. But after this point T2, you can see that between these two points there is a gap. And at this point, the finger is not touching the striker, but the striker is in motion. Clear, students? That is our observation. So the body is in motion. Now you understand the body is in motion because his finger is moving. Now what we have to now observe very carefully is that, well, what you have to observe very carefully is that the body is indeed in motion. But what you have to see is that the body which was at rest is gaining speed. The speed of the body is increasing, isn't it? So from from time t1 to t2. What is this time t1 and t2? His finger is moving along with the duster. Okay, that is this time interval. Okay, this time interval. Okay, what is happening from time t1 to t2? The speed of the body is increasing. Correct? Do you observe that the speed of the body is increasing? Speed from 0 to it is increasing. From time t1 to t2, the speed of the body is increasing. Okay, from 0 to some value v. V is the speed of the striker when his finger just lost contact with the striker. Just lost contact with the striker. The speed increased from 0 to v. Okay, from time to t. And important is where, how did it in the direction of the motion of the finger. In the direction of the motion of the finger. Did you get it? So the speed increased in this direction. Okay, so this was our observation. That is experiment number 3. Okay, friends, clear? Hello, is that clear? Yes, I suppose it is clear. Now, this is one of the observations which we have done, and most importantly, we have to further our understanding of this situation. What is that? What is that situation? Right? That is now the striker was at rest because the finger was not touching. Now the striker speed is increasing in the direction of finger because the finger is moving, the finger is doing something, the finger is compelling the striker to move. The finger is compelling the striker to move. Okay? Now here you see, students, okay, finger is compelling. So compelling, what is meant by compelling? Compelling here, the right word is that all of you know what is the finger doing? It is applying force. So our observation is very important here. What is it? That the striker's speed is increasing in the direction of the motion of the finger. Okay, and therefore the finger is applying force. The finger is applying force on the striker. Since the finger is applying force on the striker, the striker's speed is increasing. I repeat, since the finger is moving, the finger is applying force on the striker, and therefore the speed of the striker or the body here is increasing in the direction of the finger motion or in the direction of the force applied. Otherwise, the striker would have remained at rest. So therefore, very important conclusion is that there is change of motion. There is change of motion. Change of motion. Okay, there is change of motion. There is change of motion during the time interval what? T2 minus T1. During this time interval there is change of motion. Change of motion. What is the change of motion? Change of motion is what? From rest to its speed v in the direction of finger motion. In the direction of finger or in the direction of force. So there is change of motion, and therefore this change of motion is caused only by external force. So force is responsible for change of motion. Change of motion will occur if and only if there is external force acting on the body. Is it clear? Hello? Yes. Okay, fine. Now here I would like to mention a word or two about this force. Okay. Now watch out. We did another experiment with your friends. You remember? We called a friend to the stage. She stood like this with her arms like this, and we asked one of our friends to pull this right hand. So when the right hand was pulled, what happened? Your friend moved in this direction. Okay. Then he asked your friend to lift her left hand, and another friend pulled her like this. She moved like this. Okay. So why did there was change of motion? There was change of motion because of there is a change of motion of the person at the center because of what? Because of the force applied by her friends to the right and then to the left. There was change of motion, just like how the striker changed the motion. Now, when I told both the friends to apply same force on both sides, then what happened to your friend here? Your friend continued to remain in a state of rest even though two forces were acting. Now these two forces were equal in magnitude but opposite in direction. One was pulling like this, one was pulling like this. So the forces acting on the person was equal and opposite, and therefore the net force was 0. This minus this is 0. Net force is 0. I will explain this concept of net force in detail later on. At this stage you understand the net force is 0. Or now I will use one more concept here, very important. What is that concept? That concept here in this circumstances is also very important. Okay, in the given circumstances. Okay. So here you see, when your friend was standing here like this. Okay, your friend was standing like this here. Then with her arms like this, okay, your friend was at what? Your friend was at rest. Okay, and when another friend of yours pulled her like this, okay, then there was force F1 bar. Okay, now we are going to write force as F1 bar. Okay, remember, this is a notation for something, some physical quantity which has both magnitude and direction. Okay, so I told your friend to apply some force in this direction. I told your friend to pull your friend in this direction. So therefore, this what your friend did, applied force, that I am writing it as F1 bar. Okay, I will tell you why we are using bar later on. And because of that, your friend started moving in this direction. So there was motion in this direction. Motion in this direction. Correct? In the next instance, your friend was again standing here. Okay, right? With the arms like this. But this time, your other friend pulled here with the force F2 in this direction. Correct? And therefore, there was motion in this direction. There was motion in this direction. Okay? Understood, friends? So, there was motion in this direction. Okay. Now, both these motions were because of forces F1 bar and F2 bar. Now, in the third case, okay? So, what is the third case? Your friend was here. Okay? And, well, your friend was here and her two hands. So, her friends simultaneously pulled with forces F2 bar and F1 bar on both directions. Both directions they pulled forces F1 bar and F2 bar. But you see the magnitude of the forces F2 bar and F1 bar. See, this representation is called magnitude. Magnitude means how much? ಎಷ್ಟು ಘಾತ. ನಾ ಈಗೀಗ 10 ನ್ಯೂಟನ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ 10 ನ್ಯೂಟನ್, ಇಬ್ರು 10 ನ್ಯೂಟನ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಅದಕ್ಕೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಸೇಮ್. ಬಟ್ F1 ಬಾರ್ ಇಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು F2 ಬಾರ್. ವೈ? ಡೈರೆಕ್ಷನ್ಸ್ ಆರ್ ಡಿಫರೆಂಟ್. ಇದು ಉತ್ತರಕ್ಕಾದ್ರೆ ಇದು ದಕ್ಷಿಣಕ್ಕಾದ್ರೆ. ಅದಕ್ಕಾಗಿ I cannot use the same symbol, but the magnitudes are same. Therefore, under the action of these two forces, this person was at what? Was at rest. Understood? Was at rest. But here you see, when this force was applied, your friend was not at rest. And when this force applied, it was not at rest. So one more name I will just introduce here. We will call this force as unbalanced force. Unbalanced force. Okay, this force and this force, we will call it as unbalanced force. Here you see the forces are balanced. Is it clear, students? Okay? Hello, is it clear? Yes, fine. Now, we'll come back to our carom board experiment. We'll come back to this experiment for carom board. Okay, so now here in our experiment here, the striker changed its motion during the time interval t2 to t1. Correct? From the interval t1 to t2, the striker's motion changed. There was change of motion because the finger was applying force. So what was the finger applying? The finger was applying unbalanced force on the striker, and therefore its motion changed. Its motion change here means what? Its speed increased from 0 to v in a time interval delta t in the direction of the motion of the finger, or in the direction of the force applied by the finger. This is what we have understood from this experiment number 3. Okay, students, is it clear? Okay, fine. Now we will proceed with experiment number 4. We will proceed with experiment number 4. Okay, then. So our experiment number 4 will be like this. Okay, now again we will have the carom board. We have the carom board here. Sorry, we have the carom board here. Okay. We have the carom board here. We have the reference point here, the reference point over, and we had the striker here. Okay, and the finger started pushing the striker. Okay, at time t1, and then the striker continued to move, and the striker moved to this position. The striker moved to this position because the finger went on pushing it. I suppose all of you have noticed it. Okay, so here the speed was 0. Here at this instant the speed was something v is equal to v1, say some 10 meters per second or whatever, small speed. Okay, and this is at the instance t2. This is at the instance t2. And now very important observation, that is, after this instant t2, the striker did not stop here. So here you see the striker further moved. Okay, the striker started moving. Can you observe this, friends? Okay, the striker started moving. See here, after time t2, the striker is in motion. Okay, and no finger is touching. Now what I asked all of you to observe here was that at the instant when the finger lost contact with the striker, the speed was v1. Now here also the speed is v1, and as it moves further, the speed continues to be v1. So from this instant of time t2 to say, well, this instant of time. Which instant of time? Say this instant of time t3. The striker continued to move with the same speed v1. Its speed did not change. Okay. Now I asked all of you a question. How is that the striker is moving without any force being applied? Because without any unbalanced force being applied, because the finger is not applying any force. So there is no unbalanced force on the striker. How it is continuing to move? Well, one of your friends replied saying that, sir, whatever force you applied initially, because of that force it is moving. Well, that is not the appropriate answer. Yes, this is the cause. The finger touching the striker is the cause. But it is the cause for the speed changing from V is equal to 0 to V is equal to V1. The cause of the finger is to change the speed from V is equal to 0 to V is equal to V1. That is the cause. But after this time t2, the striker is continuing to move with the same speed. Finger is not responsible. That means no external unbalanced force is acting on the striker. I am sure the observation is very clear and everything is very clear. There is absolutely no doubt about that. Now students, till now we all had a perception. That is, even scientists, in those years also had the perception. That is, if force acts only, there is motion. If force acts only, there is motion. If there is no force, there will be no motion. And obviously, see, you try pushing anything in this room, if you apply force, that body is being pushed. You pull the chair in your room, you pull the book on the table, as long as you are pulling, it is moving. But once you stop pulling, it stops. So that's a very common observation. But my dear friends, okay, this experiment, if you observe carefully, it is not the case. Here you see the striker is moving on its own after this point t2. Well, that is very important for us. So henceforth, we all have to conclude that what? What is our conclusion? Okay. Force is responsible. What is responsible? Unbalanced force. Okay. Unbalanced force is responsible for what? Is responsible for change of motion. Change of motion. Okay. And very important, okay, for motion, that is, if a body is maintaining uniform motion, okay, uniform motion means what? See, now the striker from this point to this point is moving with same speed in same direction. From this point to this point, from this point to this point, the striker is moving with same speed in the same direction. This is what we call it as uniform motion. For a body having uniform motion, the body can have uniform motion. The body can have uniform motion, okay, without any force. Without any force. The body can have uniform motion without any force. This is the conclusion of this experiment. Very important conclusion. So from now on, your perception of motion must change. And this is what we have learned in both our classes. Is that clear, students? Okay, fine. Now you see, all these observations that we have done, this was very carefully observed by great scientists, especially Newton. And he summarized. Okay, so I am just telling you what he summarized. I just split his summarization into experiment 1, 2, 3, 4. But actually, what he summarized? Okay, he said, well, a body maintains its state of rest or of uniform motion. A body maintains its state of rest or of uniform motion unless acted upon by an external unbalanced force. You understood? Unless there is an external unbalanced force, the body maintains its state of rest or of uniform motion. The striker is at rest as long as the finger is not touching. The striker keeps moving with velocity v3 even though the finger is not touching. Right? So it maintains its change the motion from T1 to T2 because the finger was applying force. Afterwards, the finger is not applying force, therefore, but still the striker maintains motion. This is summarized in his first law of motion. Law means relation. Right? So that is the essence of first law motion. Newton's first law of motion. Okay, students? Okay? Well, so this is what we did. But then there was an interesting student who asked a question. Because how is it possible? How is this possible? Because we applied force to the striker initially, and because of that only the striker is moving. Because of that only the striker is moving. Huh? So how are you going to relate this to this? Well, so here Newton said there is a concept of inertia. There is a concept of inertia. Okay. So what is inertia? Well, if you take any body, if you take this, what are the properties of this body? Okay, it is yellow in color. It is got cylindrical shape. Its height is so much. Its mass is so much. Its density is so many properties it has got. Even I and you have also got so many properties. We in physics say a cat is a cat. In physics we say a cat is a cat because it has the properties of a cat. Understood? Like that, every matter, right, or many physical quantities in this universe have a property called inertia. Okay, yes. Now I can tell you this is cylindrical in shape because you can see this. It is cylindrical in shape. Its height is so much, you can see. But inertia is something that I can't show you it has inertia. I can't show you it is inertia. Okay, but I can indirectly tell you that it has inertia. Okay, I will tell you how. Now, this body, what is this body? It is matter. Okay, matter means it consists of many particles, right? We can split it into many particles. So, if you add up all those particles, it has become this body, isn't it? So, therefore, now what we shall see is this has got matter. This has got matter, and we will measure the what we can measure. We can measure the amount of matter in this. The amount of matter in this. Amount of matter means how many particles are there, etc. Not the number of particles, but totally, these particles make up this. We can measure. Okay. Now let's not complicate it. So we can use the right terms and explain this. So one thing is, I have two things here. Okay. See, this is one thing, and this is another thing. So definitely, if you touch this, you will say this is heavier. This is lighter. This is lighter than this, and this is heavier. Why this is heavier? Well, somebody said in the class, it has more mass. Correct. It has more mass. Quantity of matter in this is more. Quantity of matter in this is less. So, using a physical balance, you can measure what? The quantity of matter. Using a physical balance, physical balance, you can measure what? The amount of matter. Okay, the amount of matter. Using balance, you can measure the amount of matter. Now, what we did is, this amount of matter, we will call it as mass. Okay. Now, what did we see? More the mass, more the amount of matter, more is the mass. Okay. Now, it is very clear. You see, I have kept this in my hand. Okay. Now, I do like this. Okay. Okay. It just went off. Now, I have kept this. I did like this. You see what happened? It did not immediately go off, like how this flew off. Why? This has more mass, this has less mass. Okay? This has more mass, this has less mass, obviously. This only, I will now put it like this. This has more inertia and this has less inertia. So therefore, more mass means more mass, okay, means what? More inertia. Okay, then less mass implies what? Less inertia. More mass, more inertia, less mass, less inertia. You cannot, but one thing I want to tell you, inertia is not equal to mass. inertia is not equal to mass. At this stage students, you just have to understand that if a body has more mass, then it has more inertia. Okay, that's it. Less mass, less inertia. See, there are some things called as measure of. See, in Kannada there is a saying, Kulavanariyitu nalige. See, a person's speech, his mannerisms, his customs, the way he conducts himself, will tell, aha, what a nice person he is, what a nice boy he is, what a nice girl she is. Kulavanariyitu nalige. The way the person speaks will speak of the student's character. Understand? But his speech is not equal to his character. But by his speech, you will understand his character to some extent. So, Kulavan Ariyitu Nalige, his speech is a measure of his character. Same way, mass is a measure of inertia. At this stage, you will learn this, more of this in the next episode. Okay? Thank you very much. Good day. If you have any questions, you can post it to my email or my WhatsApp. Okay? I will definitely interact with you and help you to understand science. Science is a beautiful subject. Science is a very, very interesting subject. You need to learn science properly. Whether you use physics, chemistry, maths in your future professions, that is immaterial. But your brain will develop very nicely. You will become a very scientific person. Scientific means you will be able to reason properly. Okay? Reason properly and take decisions in life. Okay? Thank you. Good day.